With increasing global conflicts, especially in Africa and the Middle East, refugees are pouring into other areas of the world. As of today, there are over 60 million displaced people across the world, many in refugee camps with limited shelter, food, and most essentially, water. It's estimated that an average human can survive 100 hours with no water, but the greatest problem in refugee camps is not the absence of water in and of itself, but rather the absence of clean water.
Water pollution is one of the most dangerous problems within impoverished areas and refugee camps, since it's the most potent carrier of many diseases, including cholera, diphtheria, along with many hazardous microorganisms and parasites. And water is so vital to the survival that there's no choice but to drink it.
Proper water sanitation is essential to the health and survival of a community. However, it is often costly in terms of money and energy. That is why a solar-powered water sanitation device is particularly effective in polluted and strife-ridden areas.
Our product, a small solar-powered boiler, is portable and runs on the sun, a source of energy in almost all areas of the world, especially Middle Eastern and Sub-Saharan communities, which are the targets of our product. The boiler is inexpensive to build and easy to carry around. The dimensions are 40 cm in height and 30 cm in diameter, about the size of a large pot. A solar panel sits on top of the round lid, allowing it to rotate in the direction of the sun and maximizing the amount of radiation absorbed. This powers a heating plate inside the boiler, and the design allows it to hold about 14 liters of water at a time.
The outer layer is made of aluminum, which is malleable and inexpensive, and the inside is lined with anodized aluminum so it is safe to cook with. The plate is heated with a copper coil, which is the most inexpensive and effective way of heating the water. Additionally, there is an insulative blanket to wrap around the outside and trap the heat to allow for greater efficiency. This also doubles as a blanket to use during the night when there is no solar power to heat the water.
Our prototype is slightly smaller than the actual model with a ratio of 7 to 10. Instead of a hard aluminum plating, we use aluminum foil. And instead of a heating plate, we use a pink LED light to visually simulate heating the water. The round top swings open to pour water in. We believe this device is an efficient way to provide safe drinking water to communities with limited resources, and its low production price makes it accessible to many people around the world.